My name is Michelle Chang. I'm currently a sophomore studying computer science in the School of Engineering and Applied Sciences. I'm therefore a graduate of 2025. Today, I present my past summer research, which is called a full stack web application to visualize brain imaging data in 3D. My advisors were Alfredo Lucas from Penn Medicine and Dr. Catherine Davis, also from Penn Medicine. First, I present my abstract. Neuroimaging data from epilepsy patients are best represented in three-dimensional form because of the inherent spatial component. Therefore, bar graphs or other commonly used statistical tools that represent the data in 2D can be quite limiting. And that's why we wanted to create a full-stack web application that maps numerical neuroimaging data to brain atlases, ultimately creating a 3D model, and we host it onto the local browser for patients or doctors to see. The technologies we used were React, Node, Express, Python, and Blender. I had four primary objectives. My first objective was to expedite spatial representation of 2D numeric data. Second of all, I wanted to facilitate communication of results and accessibility by serving the resulting 3D model on the local web browser. Third of all, I wanted to improve work productivity and flexibility. Finally, I wanted to ameliorate the user experience by using a fast front-end language like React.js. Moving on to methods, the framework of the web application as a whole is represented as a diagram on Figure 1. To clarify, the front end of the web application was developed using React.js. Initially, the user would input a comma-separated values file or a CSV file of numerical brain data, the desired atlas, and the color. Consequently, Axios, which is a library in React which sends a HTTP request to express.js within the node.js server for each submit button in the front end. Specifically for the atlas selector and the color picker submit buttons, node.js would write the latest user's choice in a txt file after receiving the HTTP request. Finally, upon submission of the Python button, node.js would run the main Python script synchronously. The Python script runs Blender in the background and reads the txt files to update the 3D model based on the user's latest choices. Finally, the generated 3D model is sent to the local storage. After finishing the Python script, the virtual React DOM re-renders itself, updating the 3D model so that the latest 3D model is shown on that page. Now let's go to the results. Figure 2 shows screenshots of the final web application. It had two main pages, Home and 3D Viewer. The home page contained the user's inputs, the file uploader, the atlas selector, the color picker, and the run Python script command. The 3D Viewer page basically had the 3D viewer and the user could spin around the model using their mouse. Darker regions of the brain represent higher numerical values in the inputted CSV file. Thank you so much, and I was supported by the Penn Undergraduate Research Mentorship Program and the Davis Lab, which is held under the Center for Neuroengineering and Therapeutics.